are fine and safe and willing to enjoy this session number 2. Let me summarize the previous session about delivery decisions from an executive point of view. To complete more projects in less time, there are 2 strategy decisions that top management has to decide. The first one is about how to manage capacity in a dynamic and complex environment like projects. Sanjeev has already explained us 2 different ways of doing this. Local resource utilization, this is one way, and another way is global utilization, focus and finish mode. No? And this is a strategic decision that probably you have to take. This is the first idea of the session 1. The second one is how to have relevant information to be a proactive manager. As you know, when we talk about project delivery, we talk about making proactive decisions, from reactive to proactive, right? Sanjeev used the GPS analogy for projects, the Google Maps analogy. And he told us that in order to do that, we need stable project plans. We need stable roadmap plans. No? Today, we are going to see how to create an stable roadmap or project plan to help us to make delivery decisions. This is the objective of this session. Michael, President Field Operation of Realization, is going to explain us how to do it. Michael, thank you for being with us. Tell us your experience on this area.
Yeah, thank you, Manuel.
Okay.
So before I jump into the experience, let me just kind of set the framework for today. I really want to cover 2 topics in today's session. First off, right, I want to give some general examples of where we have found that this smart data model or the 2-tier planning model works very well. And so these will be some just generic examples. And then I'll go into some specific project plans where we have used these methodologies to build customers' project plans with an example in MRO, example in engineering, an example in, the first MRO is an aircraft MRO example. We'll have an engineering example, which is actually a solar panel, solar array for satellites. And then we'll have an example for a shutdown of a refinery, so maintenance on a refinery, and finally a construction example. Really today, I'm going to focus on building the tier 1 roadmap plan. I think the tier 2s are the details, which you may build at the time of planning. You may build them later on as you're in execution. And of course, that's really where the specifics come into play. And we'll talk about a little bit about how you can use integration with other systems that you have today to aid in building that second level, the tier 2 level of activities. Good. So in terms of, to answer your question, Manuel, in terms of experience, right, this is, as Sanjeev mentioned, I think last, when the first session, right, this is a solution that has evolved over time, over the last 20 years that we've been doing projects with customers. We've learned that in order to have a real stable roadmap, something significantly needed to change in the way projects were scheduled. Right? And that meaning that instead of being at the traditional lowest level of planning of where you build your schedule, we needed to build the schedule at a higher level, but still be able to capture that lower level of detail. This is really where the smart data model came from. And this is something now we have been executing for several years, about 3 to 4 years. We've been executing this with customers, and we've seen some very significant results, even for customers that have moved from the single tier plan with us to 2-tier, are seeing significant improvements in terms of cycle time and throughput. So And as I go through this, please, wherever there are questions, stop me. I want this to very much be a discussion based or open forum rather than me just presenting the information today. All right. So where do we see, and this is by no means a complete list, but some of the what we call use cases are some of the places where we see opportunities to use this smart data model and really capture the benefit of the focus and finish. And the first one is, and I'll go through some slides on these, but the first one is what we call interactive work, right? So this is where I have two different activities. I may be doing some design work, but while I'm doing that design work, I also need to be doing some analysis on that because that's going to change how my design works. So for myself as a previous engineer, when I was designing structural components, I had to constantly be going back and having someone do a structural analysis on those components to make sure that they weren't going to fail. And they would show me, okay, here's where the weak point is. I'd go back and do some more designs. And of course, what we would find is that if we worked together, we could get done a lot faster. If it was me doing some work, then sending it over to the analyst, then them sending it back, you can imagine it would take a lot longer. So we'll kind of go through an example of that. The other one is this idea of interacting resources, right? So 1 and 2 are very similar in nature, right? But oftentimes with this interacting resources, this may be where I have 2 different activities that are going on. They could be on completely different paths or different parts of the design. So if I look at like a gas turbine, right? I have design work that needs to happen in the rotor, and I have design work that needs to happen on the combustion area, and of course they interact with each other. Okay. The third area is this idea of microassembly. Right? We'll get into this, but think about maybe in like a shipbuilding where I have to have all the components to be able to put a section of the ship together, right? If I'm not focused on that, then it takes me a lot longer. So we'll go through a more detailed example on that one. Now this one may be a little controversial because we always talk about, you know, trying to break the batches, but there may be some opportunities where I specifically do want to batch. In engineering, maybe it's a set of drawings. I want to make sure all those drawings get done because I need them for you know, to do a final assembly build or something like that. So there may be some opportunities where batching is a good thing. Finally, then what we call enforcing an execution sequence. So there may be some reason why, even though I can do, you know, A before B, or I can do B before C, there may be for risk mitigation or something else, there may be a reason why I want to do things in certain order. Right? So at this high level flow, I can really use the dependencies to help drive that sequence. At the same time, there may be opportunities where there's at the detail level, I have a lot of flexibility, and I don't want to set hard dependencies during the scheduling. I want there to be the opportunity for you know, engineers or mechanics or artisans, whoever, to be able to move things around very freely. So I don't want to have them part of the roadmap. I want them to be the details down below and really have execution drive the order in which they're done. And then the final example that works well with this is what we call the rolling wave planning. Right? So in other words, it's this agile idea where oftentimes the work that I finish will really drive what are the next steps that I need to do. So again, at a high level, I can define some steps, but at the details, I'm really only be able to look out maybe a month or 2 months in the future and really decide what are those detail steps that I want to do next. Okay, so let me go into each one of these in a little more detail. And as I said, then we'll jump into some project plans. And when I was given that example, I do this all too often. I kind of flipped the two. So let me go back and be more specific about this interactive work. Right. So this is the example I gave with a gas turbine. Right. When we worked, this is actually from a customer we were working with. We developed this. What we recognized was that each group in the organization, so they had a turbine group, they had a compressor group, they had about 7 different groups if you broke the gas turbine into its individual components. And each one really had their own project plan that they were working to. And what would happen was, even though they initially set out in their master plan to have work being done at the same time, because of the normal uncertainties, because of delays and things of that nature, right? Now they ended up becoming separated, right? In other words, while I call this blade 1 versus blade 2. So inside of a turbine, of course, you have your rotor, you have your blades, you have your casing. And as turbine is designing a new blade, well, what they're doing on that actually impacts the blades inside the compressor. It impacts the design of the casing. It even can impact the design of the shaft through the turbine itself. And so oftentimes their project plan, they'd end up with a situation where turbine group would be working on their blade, and now they needed input from somebody else from the compressor group. But because of, again, the natural uncertainties, delays that were happening, compressor wasn't to that point. And they had one of two choices. They could either move forward at risk, make some assumptions, or they could stop the whole, stop their portion of the project and go off and do something else. And Sanjay, you've already talked about, what happens when you stop and you move on. Right? So what this led to was, we really wanted to define all of this blade 1 work for the turbine group, the compressor, the casing, as one task in the network. Right? So from a tier 1 level, we ended up creating one blade 1 task, and each group had a subtask underneath that. And what this led to was, now the priority for each of the groups was the same. If one was delayed, right, or I shouldn't say if one was delayed, but as uncertainties happened in other projects or in other work streams, this task now moved in its entirety. Right? When we went to start this task, now we made sure we had all the resources that we needed from all the groups to be able to do this as quickly as we could. So really, the idea was here, making sure that we had all the resources that we need. They were focused. Their priority was synchronized. I'll pause on each one of these and see, is there any questions that people have? So this idea of interactive work. Okay? Oftentimes in aerospace is a great example. There's many different parts. If I'm designing a new fuselage or a new wing or an entire new aircraft, there's a lot of different parts. And some of these parts can have very long lead times. Some of these parts may have extremely short lead times. I take as an example, let's say I'm doing a casting for a new trunnion on an aircraft, or some significant structural part of an aircraft, and it's starting as a casting. Well, of course, you can imagine that's going to have a very long lead time on it. Some of these have a lead time of greater than a year to get a casting, then to do some machining on it, and so on, before I can finally put it in the aircraft. However, along with these castings, I have a lot of other little pieces that need to be attached to that. They could be like clips and fasteners and mounting tabs for wire bundles, for hydraulic lines, whatever needs to be attached to it. And these are oftentimes very simple parts, right? They're stampings. They may be a quick machined part or something like this, where their lead time may be days or even weeks. What we found was happening was that as they were designing the castings to get them out for the long lead, they were ignoring the clips and fasteners and all that, and waiting and designing those later. When they would come to design those, now they would find that there was some sort of an interference. Well, the way I want to design the clip to optimize weight or to optimize cost or something else, it doesn't mount correctly on the casting. It doesn't work correctly. So now something has to give. Do I change the design of the casting and potentially cause my lead time to grow even more in the casting? Do I sub-optimize my weight by changing the design of that clip or fastener, right? And while you may say, okay, just a simple thing, sub-optimize the weight, that's a huge thing when you're talking about an aircraft, right? Changes of 1% and 2% of weight can be a significant impact on the overall long-term operating cost of an aircraft, right? So what we worked with our customer on was really identifying for each of these castings, what are the clips and mounts and fasteners that need to be designed at the same time, and we grouped those together. So now instead of thinking of the clips as a short lead time, we really said, okay, what are those areas that interfere or interact? Pull those designs up ahead with the long lead items, design them both at the same time, and now we can end up actually reducing lead time later on because we don't have changes to the casting, as well as we can make a more optimal design overall because we're not having to make these compromises later on the clips and fasteners. And while it ended up changing the flow of the project, right, and required a little bit of more thought of how should we staff the project, right, the impact was a significant reduction in the overall lead time. So I'll pause here again. Any questions? And does this make sense for the interactive work?
Yes. Okay.
All right. Thank you. Next is this idea of interacting resources. Okay, so you've all been in situations where I'm trying to design something. Now I may be designing from an engineering standpoint. I may be trying to do some work in MRO. I may be trying to come up with a new solution inside of a construction. But in all the cases, it's the same. I do some work. I need to have a review. Maybe there's some rework that has to happen. And I finally get to, I'm done. I can go ahead and do whatever my decision was. Okay, changes to a design in construction, changes to a part model inside of engineering or whatever. Okay. And while that flow is not something that we can really change, the idea here is that if I've broken them out as individual tasks, there's the opportunity, and again, I'm going back to what Sanjeev talked about in the first session. There's this opportunity that when I finish the drawings and I try to put my review together, right, now I don't have people really ready. They're off on other priorities. It doesn't carry the same priority as doing my initial drawing. So I may end up having a significant amount of delay in the time that it takes between doing my drawing and actually getting that review done. Same goes true for then once that review is done, because now let's say I am an engineer and I'm trying to get a drawing reviewed. I've sent it over. I realize that it's really uncertain when I'm going to get it back. So now I'll go off and start working on something else. If all of a sudden it comes back to me in just a day or 2 days, I'm probably not ready for it. I'm still working on something else. It's going to be 3 or 4 days before I'm going to be able to do that rework. And this cycle continues on. So the idea was to really create this single task, very focused, make sure that once I start my drawing, I already have those resources aligned for who's going to do the review, turn that review into more of a workshop mode. And that's maybe something for a different discussion. But this idea of doing the review, doing the rework, and doing the approval all at the same time. So pulling everybody together, taking the drawing, finalizing it, and being done. We have found that where these streams could typically take 2 weeks or even longer to get through the drawing to the final approval, organizations can now finish the drawing and have the approval done within a day or less. And the idea here is that rather than having each of these activities carry a potentially different priority for folks, now because they're all grouped together and we're prioritizing one activity, this overall work stream, Now we have all the everybody that's involved in all these individual activities carrying the same priority. Okay. Please help me make sure these are making sense, and let me know if there's any questions. All right.
Any questions? Wait, Michael.
Yeah, no problem.
Any questions about that?
No questions, Manuel.
Sorry?
No questions.
No questions. Okay. Our customers are very smart. And
Yeah, I think there's some I think people have tried these things. It's difficult when the software doesn't support it.
Mhm.
So this is we call this micro assembly. So let me kind of lay this out. And this is this example came from shipbuilding, but of course it can go into construction as well. Anytime when you have kind of large constructions that you're doing, and those construction can be broken down into smaller sub-assemblies. Right? So even in engineering and design, maybe I have sub-assemblies. But in order to really do the assembly on the ship, I break the ship down into these larger sections, if you will. Okay. And from these larger sections, I break those down into another sub-assembly, and then finally I get down into individual plates. So a section of a ship is a lot of plates of steel, and there's specific cuts that have to happen of those. Oftentimes, right, to try to optimize the fabrication, we try to cut all the plates that are similar. So this means I look at all the designs and I say, okay, this cut plate 1, there's one of those in section A, there's one of those in subsection B, and there's one of those in subsection C. Same happens with cut plate number 2, right? There's one of those in subsection A, subsection B and C, and so on. Right? So instead of, what happens now is that as I'm moving along, I keep getting plates, but I get a few plates for subsection A, a few plates for subsection B, and a few plates for subsection C. Right? And it's not until I get the last plate am I able to start doing the fabrication on any one of these subsections. So you can imagine now that I work really hard on cutting plates, but the subsections are waiting and waiting and waiting and waiting, and now all of a sudden they have everything. And there's more subsections than they can possibly work on. They don't have that many welders. They don't have that much space to be able to work. So now I have to start prioritizing my subsections. And pretty soon I do subsection A, then I do subsection B, and so on. Right? So again, I work really hard, but I still can't start any of my overall section fabrication because I have to wait until all of these subsections are now done, because I'm not finishing any one of them ahead of the others. Right? So this draws out my overall cycle time of my workflow from the time that I cut my first plate until I can actually get that section 1 completed. And this continues to carry on into the next section 2, section 3, which is really what my ship is assembled into, all these different sections being welded together. So instead of doing this, right, of course, we broke it down into what do I need to do for subsection A? Get all those plates. As soon as I have all those, now I can do subsection A. While I'm working on subsection A, now I'm doing the plates for subsection B. Once I start working on subsection B, I can already move section A into place and start doing my overall section fabrication. So you can imagine now that instead of having everybody working really hard, but the overall flow of the stream getting interrupted, now as people are working, the flow is moving right along with them. This really goes back to that example that Sanjeev gave last time, where he showed you that you had the 3 different, the blue resources, the green resources, and so on, right? Them working in parallel and stretching everything out versus being able to flow through the constraint and shorten the cycle time significantly. So it's really about looking for how do I find kind of what is my constraint, what should set my flow, and making sure that I am subordinating back before that and scheduling the work to be done into those as well, right? So you can see that now the subsection became my task and the cutting of plates became my subtasks. And of course, there'd be another subtask for cutting of subsection or cutting the plates of subsection B and so on. So I think this is one place where we actually use the methodology to help us break the idea of batching. Questions? Okay, I'll move on. Now, on the flip side of this, we're actually going to talk about how do I want to batch in order to actually save on time as well. Right. So this actually, again, came from an example, not in shipbuilding, but in ship maintenance. So here I need to remove a lot of items from inside of the ship. And in order to do that, right, I have to have my cranes and my riggers that can lift everything out. And again, it kind of got to this idea of, you know, what are those things that I need to get out first because they take a long time to repair? What are things that I can take out later because they take less time to repair? And the traditional schedule, they would start by going in and removing all the pumps because they were a very long lead. Right? They would finally come in and they would remove the valves in each area. Right? And so every time they would go to, so if I was in area 1 and I'd pull my pumps, I'd move my crane over there, I'd move all my pumps out. Then I'd come back maybe a week later, maybe a month later, and I'd go to remove my valves. I'd have to move the crane and the riggers and everything again. All right? And this continued on, removing the panels, removing piping, and so on. And while, again, everybody was busy, everybody was focused on, okay, let's get all the long leads. Now let's get all the medium lead repair items. Let's get all the things that are just a direct replacement with new, so I don't have to do any overhaul. I'm just removing and replacing. Let's pull those out. The time that it was taking, there was constant delays because I was always waiting for the crane and the riggers and even space availability. I was constantly waiting for those things to line up so that I could do each of these removals. So rather than that, we focused on, okay, let's stage for area 1. That became our tier 1. And let's remove everything that needs to be done inside of area 1 at the same time. Let's bring in all the resources that we need, remove the pumps, the valves. Let's only bring the crane in once. And as soon as that's done, let's move to the next area. Mm-hmm. What we found here was that the time that it took to actually remove everything was only a very small increase in the overall time that you were spending in that area. Right? Maybe a 10% increase, but the reduction in cycle time to get everything out of the ship was significant. We were able to get everything out of the ship in 30% less time. And still we were able to get now we had everything out before the first item had to leave that was a long lead for overhaul. So while we talk about, you know, it's not always the best idea to batch, there are some times when the constraint is such that we really do want to batch to minimize the impact or minimize the amount, in this case, the amount of movement that we had to do on our constraint, which was our crane and riggers. And so anytime we want to group those together, we group them as subtasks under a single tier 1. Does this make sense?
You can use your camera if you want to ask something. Put your camera and your micro, okay?
So let's look at an example from construction where we've used this idea of the tier 1 or the smart data model with the tier 1 and tier 2 activities to enforce this idea of an execution schedule. So this is an example from a large apartment construction project. And this is focused mainly, this example was focused around kind of doing the finishing work in there. So once I move in to do finishing work, maybe I bring in my tile setters. And as I'm doing my tile, right, people will start to look at, okay, what is all the work that I need to do? So I have all these different apartments that I need to work on. And in each apartment, I have different rooms that need to be tiled. Okay. And oftentimes what would happen is that I would bring in maybe all the, let's say room A was the bathroom. I would bring in all my bathroom tile. And so my tile crews, they would want to move from bathroom to bathroom to bathroom. Then they'd want to come back and they'd want to do all the tile in the kitchens. Then they'd come back and they'd want to do all the tile, let's say, in the entryway. Those are my 3 rooms. However, until all the tile is done, I can't have my other trades come in, right? They can't be walking across the floor. They can't be putting cabinets in. They can't be doing finishing on the walls or electrical or anything like this, right? So again, while the tile folks are very busy, all my other trades are sitting and waiting. They're waiting for them to get completely done. So what we do now is we take and say, okay, from a tile perspective, I want to bring a crew in. I want to put them in apartment 1, and I want to get all the tile done. Do the bathroom, do the kitchen, do the entryway, whatever tile needs to be done. Once that is done, then move on to apartment 2. Now my other trades can come in behind them in apartment 1 and get started. So I'm probably not significantly reducing the cycle time for my individual tile, but in the overall flow of the project, I'm significantly reducing my cycle time because now my next trades can come in. This is one example of where we use the idea of grouping things together. In this case, I grouped all 3 of the rooms in each apartment into one task and drove the sequence of how I wanted work to be done by the folks doing tile. Again, this holds true for my drywall folks. This holds true for my other flooring activities, whether I'm doing carpet, whether I'm doing some sort of a wood floor, right? This can even be in terms of when I'm doing my glazing, putting all my glass and everything in construction, right? If I'm not focused on sealing up an entire area, then I can't bring other things in to finish up inside. So there's many opportunities where driving this sequence in a construction project can help reduce the overall cycle time of the project. Questions here? We have just a few more to go through. On the other hand, I may want to use this smart data model to help force the sequence to be flexible. Right? In other words, if I build a single level plan, I may try to force my civil design to happen before my mechanical design and before my electrical design. Again, this is looking at a construction project. Okay. The reality is, though, that really there's not a clean break. I cannot finish my civil design before my mechanical design starts. And I can't finish my mechanical design before my electrical design. I can get most of it done, but there's going to be changes. You know, as mechanical's working, there's going to be some changes that have to happen in civil. As my electrical is happening, there's going to be some changes that have to happen in mechanical, which might flow all the way back to my civil design. Okay. So instead of thinking these as individual activities that happen one after the other, I really want to have all of my resources working together. This kind of gets to that interactive that we were talking about before. And I want one task. I want to have one design task and all three groups working together. We also saw this, we've used this many times in like aircraft, aerospace manufacturing or design, right? Where you have a lot of different engineers working, from structural engineers to electrical engineers, mechanical engineers. Instead of having each of them working independently, we now focus them to work together on one design task. We identify what are all the subtasks that need to be done, and they work in this collaborative group mode, if you will, all working on the same priority to get like one section of an aircraft designed or an entire wing designed all together. And so it's a very interactive. Okay, so we're actually using this idea of having at the roadmap level, it's just the overall design. Below that, the civil, the mechanical, and electrical, there's just a lot of interactive work going on, and we're not specifically tying dependencies at that level. We're not making a dependency that I have to finish the civil before I do the mechanical or before I do the electrical and so on. The final is this idea of being able to do a rolling wave planning. Some people call this agile, right? And really what we're talking about here is oftentimes I can't define everything that has to happen in the project on day one. These can be very long projects that may be, years of development that have to happen, and coming up with all the steps that need to be done 6 months, a year, 13, 14 months from now is just not feasible. But at a roadmap level, I know intuitively what am I going to do, right? So this is an example for a large software upgrade project where I'm developing modules, and oftentimes what happens in the first module is going to dictate what it is I'm going to do in the second module and what I'm going to do in the third module. And so while I might be able to begin with the details of my first module, right, I'm going to wait until I'm nearly done with the design in the first module before I define the activities that are going to happen in the design of the second module. So this idea of being able to develop a roadmap which I can follow, but actually be able to add the details of that later on, and not influence or change my overall schedule, allows me to have a very stable plan, as Sanjeev and Manuel have talked about. Right? Have a stable plan because the roadmap is there, but still allow me to have changes as I go along. We also see this a lot of time in maintenance, where the repairs that I have to do, whether it is in an aircraft maintenance, or a vehicle maintenance, or whether it's in shutdown and turnarounds for refineries or steel plants or something like this, while I can design the roadmap and put in some high-level activities for I'm going to do repairs, I don't know all the details of that until I've actually finished my inspections. So this gives me a way to, again, build that roadmap and add my details later. Okay. So these are all just some generic examples that I wanted to go through. What I will do now is I'll jump over. I'll pause here to see if there's any questions on any of these generic examples. But then I'll jump over to some actual project plans, and we'll walk through the framework of how we have built the tier 1 plans. And maybe we'll get into a little bit of the tier 2 details, but really I want to stay focused on just the tier 1 details today. So any questions that you have, or Manuel, anything that you want to add as I move forward?
I think it's clear. And the way of modeling our customers plan projects in this way. Maybe if you explain examples, different examples, I think it's better.
Yeah.
But perhaps the main obstacle to implement this idea is who is going to manage tier 1.
Yeah, we'll get to that. That's good. That's good. Let me get into the actual project plans, and I think that that'll become more clear.
Okay.
Okay. All right. So let me jump into an example from engineering first of a project plan. This is actually a solar, designing and building a set of solar panels for a satellite. And at the tier 1 level, at a traditional project plan, this project plan would have about 180 tasks. This project plan today has a roadmap that's only, this is not the final one, but this final project plan only has about 18 tier 1 tasks in the roadmap today, right? So we've taken 180 overall activities and we've brought that down to a flow or a roadmap of about 18 steps. And if I look, I'm going to shrink this down here. If I look across the top, of course, there's some phases that my project's going to go through. I'm going to do some design work in engineering. And I really want to make sure I get all the design work done as soon as I can. So I have a milestone that helps drive me to get that done. I'm going to go out and buy some materials. Now, this is a situation where this is a customer that buys all of their components. They don't build any in-house. They buy all their components. Right? It may be that you're actually doing some manufacturing in yours as well. We then move into assembly, integration, and test. So taking all the components and assembling them together. So I really want to make sure I have this full kit. I really want to make sure that I'm using the full kit to get all the materials that I need back. Is there something dropped down? I didn't know if there's a question or what there. Sorry. But I use this full kit to make sure I have all the materials that I need to be able to move into assembly as quickly as possible. Now, this is one place where, of course, integration is, we can use Concerto to integrate with other systems. Let's say you have an ERP system where you're tracking all of your materials that you're buying. The full kit can link into or integrate with that ERP system, identify all the different materials that you're buying, and be fed from, first it can feed to the ERP system, when do I need these to be able to do the assembly on time? And it can be receiving from ERP, when are the materials going to be arriving, so I can see if there's going to cause any delays in my project overall. And now if I expand this back out, right? Some of this idea of, that we went through with interactive and really deciding or having flexibility in the sequence. If I look at this preliminary analysis, if I look underneath this, I have a set of activities such as some structural analysis, some thermal analysis. There's a lot of different tests that need to happen on the design before I can actually finalize it and send that design out for build, or for the vendors to build it. Right? But one of the things that our customer identified was that really it's impossible to define the exact order in which these tests need to take place. I know what resources I need. I know about how long each one of them should take. And I believe they said if we have everybody, we can get this done in about a month. Right now, again, this usually was taking more like two months or longer to get this all done. But they said if we have everybody and we focus on it, we can get it done in a month. So we built the tier 1 task to be a month long. And we identified all the different tests that might have to happen. But in execution, there's a lot of flexibility on what order they do these in and which tests they will actually have to do. So I can go in and change the order of these. I can delete these tests. I can even add more tests without impacting the top roadmap or the tier 1 level of my project plan. So now I do some design work. I do my analysis. I have a review. And from there, I end up doing all my finalized drawings, right? This is one place where this actually got consolidated a lot more in the final design or the final project. But I do my drawings, okay? And that leads into now being able to go off and purchase. So if I think about just kind of the flow, overall flow of how I would discuss, even though there's many steps that have to happen, this roadmap now makes sense to everybody. I do some design work. I do some analysis. I do a final design. I do all of my different drawings that have to happen, from assembly drawings to test drawings and all of that. Once all that engineering is done, I go to the vendors, I buy stuff. Then I come back to my assembly where I do some of my sub-assembly work. I do some testing, and I finally put it all together and ship it out to the satellite manufacturer. Okay. So the roadmap is very simple to explain. It's very simple to follow. And when I'm really talking about, okay, where am I stuck? Right, I can now talk about, well, I'm stuck in my analysis, or I'm stuck in getting all of my drawings produced. That makes sense to all levels. And you can imagine, in this case, Manuel was talking about, who's responsible for this. If I look at this analysis, there's a lot of different skill sets that are needed inside of this. It's not just one resource type. So while these are individual activities being performed by individual engineers, at the tier 1 level, it's really more of a management role to manage all of this work. Right? In some small projects, it might be the project manager. In smaller organizations, or sorry, in larger projects, this may be something like a resource manager, right? Or it may be a design lead or something like this. So it's a little bit more of a management role now at the task management. It's not somebody that's doing the work, but it's somebody that's seeing, prioritizing, and has the oversight for a larger group of individuals to make sure all of this work is happening at the same time.
Okay.
But I think that's an important thing, is that the roadmap should be something that you can explain very simply and it makes sense. And when we're building this, we oftentimes start with this idea of kind of what are my phases, and now what am I doing? So engineering being one of my phases, and what am I doing inside of that engineering? I know I'm getting a little short on time, so I'm going to keep moving through some of these examples. This is an example of a maintenance shutdown where this is actually for an aluminum refinery. Okay? And again, I have this kind of matrixed approach now where across the top, I have different phases. I'm ramping down and decommissioning and on the left-hand side is really all the different systems in the plant that need to have some work done to them. So I have to do a ramp down and decommissioning of the overall. I have to open up and get access, right? So I got to open up things so that I can start doing inspections. Then I have to actually do my overhaul. Some of this may be planned ahead of time. Some of this may be things that I find when I'm doing the inspections. Okay.
Mm-hmm.
I think I jumped over a section there. Nope, over. Right. Then I'm actually getting into, once everything's getting closed up, I start commissioning and bringing the system back online. right? And my project is over. So I have these 5 very distinct phases. And inside of each of those, and let's go into the overhaul, this is kind of where most of the work is being done. For each system, right? Now there's some overall high level things like making sure that electrical is either I'm tagging out my electrical systems or I'm bringing in some temporary systems that I need. Scaffolding, right? I'm building, of course, I'm erecting all my scaffolding, all my safeties, things that I need. But then I get into the different systems where now I'm actually bringing these systems down. And underneath each of these activities, I now have specific work instructions. Okay? So for those of you that work in maintenance, you'll be familiar with the idea of a work card or a work instruction. And these are typically managed by some sort of a work card or work management, work breakdown system. And Concerto actually, again, we interface with those systems. So instead of bringing these activities in manually, right? Once we've built the tier 1 structure, Concerto now goes out and identifies what are the work cards that need to be done when I'm working on this system, when I'm doing the rebuild and overhaul of this system. What are the work cards that need to be done? So there's a little bit of mapping that has to be done between Concerto and whatever your work card management system is. But this holds true to whether it's aircraft maintenance, vehicle maintenance, ship maintenance, right? And the systems actually work together. So now as engineering is creating new work cards, I have an inspection, I find a problem, engineering creates a new work card, that work is automatically loaded into Concerto, and we can see what is the impact. Does it now mean that this task is going to take longer than we originally thought? So again, I've built my roadmap. My roadmap doesn't change. It's a very stable plan. I can count on the dependencies that I have in there. But the details below, I can make changes to that, and I can immediately see, are those changes going to cause impact in the overall flow of my project or on one certain stream of my project? So in large maintenance programs, I have my phases that I'm going to go through. I have my systems that I'm going to work on. And you can imagine that sometimes there's different steps for each of those. They get broken down into a roadmap for each stream of activity. Pardon me here for a second. Jump over to this one. I'll stay on the maintenance side for just a minute as another example of a project plan. Right, so this is an actual aircraft maintenance. And one of the things that you'll see here in a second is this is a situation where I really have to be able to do the rolling wave planning because I don't have any real planned repairs. It's all based on the inspections that I find. So I start here with, before I bring the aircraft in the hangar, I have to do some work. Right? There's some parts of the on the left-hand side is how this customer broke their aircraft down into sections. And again, this is these examples are something that, you know, you can tailor to your exact environment. If you're in the maintenance world, right, you may break your aircraft down differently. Right? You may not have an upper and lower fuselage. You may just have the fuselage, or you may break out different sections of the fuselage versus upper and lower. Right? That's all something you can configure for your environment. Once I've come in the hangar, now I have to open up all these sections. Right? So you can see that underneath any of one of these, I have certain work cards that need to be done. Again, these are work cards that are managed inside of another system. And as these work cards are created, they're mapped into Concerto and pulled in automatically. Once I've done my inspections, now you'll see that inside of repair, all of these repairs are actually blank. So if I open one of these up, we've taken an estimate or a guess on how long it will take. And of course, we're using historical data. How long do we think it'll take? What resources do we think we need? So we've built the roadmap. Pardon me. We've built that level of the roadmap. Now, as we find problems that need to be fixed, as we create those work cards, if Concerto sees that it's going to be significantly more than 3 days, if it starts becoming 4, 5, 6 days, we're going to see that immediately inside of the system. It's going to tell us that, okay, the work you've put below is now more than the time you have allotted, or it's going to require more resources than what you had originally planned. So we can go in and analyze that. And again, we can be proactive. We're still in the inspections, creating these work cards, and we already know if we're going to have a problem inside of repair. So bear with me going over here just a minute. I'll go through a construction project plan really quickly. But the idea is really still kind of the same, that I have some phases across the top. Now you'll see I started all the way back with contracts on this. Then we're doing some engineering or architectural work, ordering materials, some more design work. Now we start doing our civil work. We have our civil work that has to be done, all of our groundwork. This is a, this is a thermal power plant construction, by the way. Then we start doing the actual erection or the construction of the project itself. Finally, the commissioning and the project end. Okay. On the left-hand side, I have all the different systems. So my steam generators, right? My hydro systems, my boilers, okay, all my environmental systems, the soot blowing, right? Of course, they're all going to be different for your exact environment. But on the left-hand side, I have the different systems that I need to construct, and I have what, you know, the different phases they need to go through. Now, for each one of these, right, I can create kind of my own little, what are the high-level activities that need to happen in order to, like for this soot blowing system, I have to do some basic engineering. And you can see this is one where they've already started to put a little bit of detail to it. Maybe I got logged out of this one. There we go. There we go. All right. So for them, they have a first submission, a final, you know, and then they get that back. They have to do another submission and they get their final approval. So we've decided how long it will take overall. What is the effort that needs to be done? Right? And that gets them through their engineering. Right? Then they can start ordering materials. For some things, they don't have to do actual upfront engineering, right? So for this air and gas ducting, instead of doing the upfront engineering, they can just go right into making their civil drawings. This is a system that it is already predefined. They're ordering it from a vendor, right? So they just have to make sure that they have all of the civil work done based on the system. So how big does the concrete pads need to be? What safety structures do they need? What structural components do they need? And so on. So for each system, in this case, we're defining what is the flow. And we may find that sometimes these systems are kind of interactive, and we may start creating one task that goes across multiple systems, as we saw with like the gas turbine, where we were talking about the rotor, the casing, the combustion, right? Where multiple systems need to be worked at the same time. Now, well, I apologize for going a little bit over here.
It's okay. It's clear.
But let me just summarize really quickly, if you will, kind of what we see as best practices for creating the project roadmap. Okay. First, the first step is really creating the plan. And whether you're doing it from a top down, whether you're doing it from a bottom up, right, it's going to be different for every environment. If you know the details, we can start with what are the tier 2s and we can build the tier 1s from that. If you really, you know, if you just know the roadmap, we can build the roadmap and add the details to that later. It works either way. The key first is to just start putting down what are the milestones, what are those phases, what are the activities that you need to do in each one of those, what are the systems that you need to work on. And then you can start kind of iterating that plan a little bit. Okay. Really start looking at, okay, are these two activities that are in parallel really isolated from each other, or do they need to be worked together? Should I group them together into one larger tier 1 activity? So those are the iterations that we're talking about. And we can start adding more and more tier 2 activities to the plan, whether we do it before we go live or whether we do it in this rolling wave approach, where maybe I'm planning out the next 30 days, 60 days, 90 days, whatever I can in iterations.
Mm-hmm.
Okay. The idea here is thinking back to the GPS. Right? I really want to have a very easy to follow roadmap that tells me where am I today and where do I want to get to. The details are something that I want to capture at the next level down, because I need those. I need to make sure I'm getting all my drawings done. I need to make sure that I'm getting, you know, every one of my rooms finished, all the electrical, all the tile, all of that. Right? But that's not really the roadmap. The roadmap is something higher.
Very good, Michael. Any questions? Okay, section 3 depends on you. You decide if you want to do it, because we prefer to make it individually and to apply what Michael told us today to your projects. And if somebody wants to fix a date, send us an email, please. If no questions, thank you again for attending, and thank you to Realization, Sanji and Michael. And I hope that these ideas help in your projects, because the main objective is to make more projects in less time and to be a proactive manager.
Mhm.
This is the idea of the sessions.
Sorry, one question. This is Aroa Calvo speaking. Could you share the presentations or?
Yeah, yes.
Okay.
Mm-hmm.
Okay, thank you.
We will share the presentation and the video of the session.
Okay, great.
Michael,
Yes, ma'am.
thank you very much, but no questions. I don't know.
Okay.
Everybody knows a lot.
Yeah.
Because, so,
Okay.
okay. Thank you very much again.
No, thank you very much for having me. Thank you for the time. I appreciate it. Thank you.
Thank you. Bye.
Bye now.
Thank you. Thank you.
Bye.
Thank you, Michael. Thank you, Manuel.
Bye.
Bye.
Thank you. Bye.
Bye bye.
Thank you. Bye.
Bye.